governance minimized protocols will see the most use. It is the core attribute which kicks off the positive feedback loop between trust and adoption as a standard. Welcome to Ethereum Audible. I'm Yoshua Zlatogorsky, and welcome to Ethereum in Depth, Ethereum where we read the best articles in the Ethereum ecosystem, Web3, on-chain governance. That's what we are diving into over last week, this week, and next week again. Fascinating topic, super relevant, and involved in all kinds of different projects, DAOs, and just a big issue that involves governance, political science, and of course, blockchain. Today, we're going to be reading Governance Minimization by Ehrsam and Dan Robinson. But first, I want to thank the sponsor that makes this show possible. This episode is brought to you by Alpe Audio. Want to learn on the go but need more depth than a podcast? Alpe is the app for you. It's an audio education app that brings great in-depth courses that are as fun as podcasts, but as educational as a degree. Each lesson comes with summaries, additional resources, flashcards, and more. You can even find Ethereum Audible on Alpe with all of those additional resources. If you want to check it out, head over to get.alpeaudio.com, and that's A-L-P-E, Alpe, A-L-P-E. Let's go. Governance Minimization by Ehrsam, co-authored by Dan Robinson. The best government is that which governs least. Quote, by Unknown. Those who read my blockchain post from 2017 know I was excited about crypto exploring different forms of governance, especially on-chain governance. In the 3 years since, on-chain governance has gone from obscure to a popular component of many important protocols. Despite this traction, I think the most widely used protocols will trend towards governance minimization. Why? Governance minimization allows stakeholders to depend on a protocol. This creates a virtuous cycle of adoption, enabling scale that would otherwise be unachievable. Look no further than successful traditional internet protocols like HTTP and SMTP to see this power today. Their governance minimization has allowed them to become standards everyone depends on, generating levels of use far exceeding what any company could achieve. This post explains governance minimization, where governance remains important, and speculates on implications. Governance minimization. Governance minimization means reducing the power and reliance on governance wherever possible. Governance minimization is important because it supports the primary value proposition of protocols, credible neutrality. Minimizing governance tends to make protocols more credibly neutral. In practice today, governance minimization most directly applies to minimizing on-chain governance. If a protocol wants to achieve maximum adoption and can avoid using governance for a function, it should do so. What is credible neutrality? Credible neutrality is dependability. It means a stakeholder, example, a user or a developer, can use or build on a protocol with confidence it will not change against their interests. Protocols remain credibly neutral by avoiding capture by any particular group. Why is credible neutrality important? Credible neutrality is primary value proposition of crypto today. It's what allows for new forms of open and predictable money. It's what creates platforms where anyone can openly create and access new applications. Lack of credible neutrality in existing platforms makes its importance clear. Central banks are not credibly neutral as platforms for money because a subset of stakeholders can decide to print money at will. Facebook and Twitter are not credibly neutral as platforms for applications because a subset of stakeholders can make changes that kill entire developer ecosystems. It creates safety of value locked in a platform, both concrete, like funds, and abstract, like development time and users, from theft, shutdown, and restrictions. A total failure of credible neutrality is an exit scam. Some stakeholders of a platform can abscond, in part or in whole, with the value other stakeholders own or have created. A literal example is a centralized crypto exchange operator running off with user funds. An abstract example is Twitter, shutting down third-party developer interfaces to enshrine the interface of Twitter Inc. What governance minimization is not. Governance minimization is not the idea that governance can or should go away entirely. In fact, this is impossible. There are some protocol functions that are hard or impossible to perform without governance, essential governance, and more on this later. And at a minimum, governance always exists through the ability to coordinate socially, as in informally, and hard fork. Governance minimization creates more neutral protocols. Creating a perfect governance system is like designing a perpetual motion device. There are well-known game theoretic results which show all governance systems are both inherently unstable and fail to simultaneously satisfy all desirable properties. Formalizing a governance system tends to magnify these inherent issues by reducing the ability for informal governance to solve edge cases as they show up. As a result, the more formal a governance system, the more susceptible it tends to be to capture over a sufficient time horizon. This is primarily because formalizing a governance system requires formalizing stakeholders, as in who has a say and how much of a say they should have. Formalizing stakeholders is very hard in practice at a single point in time and near impossible over time. Token holder misalignment. Formalizing stakeholders for on-chain governance today typically occurs through simple token ownership and the governance itself through token holder voting. Unfortunately, token holders are not an accurate reflection of stakeholder value in a protocol for a number of reasons, including 1. Not all stakeholders will necessarily be token holders, especially users and developers. 2. Token ownership may not accurately reflect a stakeholder's importance to the protocol, present or future. The next Facebook or Google scale app, when it appears, could be strangled in the cradle by those with higher ownership. And 3. Stakeholders change over time. This is especially obvious when considering future stakeholders which don't yet exist. Consider the interests of the mega app which has yet to be created. As a result, token holder voting creates a litany of misalignment issues with the long-term use of a protocol, including 1. External pressures. For example, Facebook faced external pressures to lock down developer access to the most detailed social graph in the world, the Facebook platform. Right or wrong, this killed many applications, an incalculable number of future applications yet to be created. 2. Value capture. Token holders may want to capture value for themselves at the expense of others. For example, Twitter monopolized its protocol's UI at the expense of third-party developers. 3. Time horizon mismatch. Unlike a protocol, token holders have non-infinite time horizons. This may drive them to capture value short-term at the expense of the long-term use of the protocol. For example, Maker holders with a short-term horizon might increase stability fees to generate value short-term, irrespective of long-term impacts. Ironically, Facebook is a good example of the opposite, where Mark Zuckerberg famously refused to display ads as in capture value while the network effects of Facebook was still growing. 4. Outside economic interests. Token holders may be large holders of another token and vote with that interest in mind rather than the interests of the protocol being changed. Liquidity mining programs in DeFi are especially vulnerable to this form of misalignment. Exploits to act on these misalignments are well documented and hard to avoid. Prominent attacks include buying votes or voting with borrowed tokens, an attack made easier with the invention of flash loans that has already worked. Other side effects. Even if participants don't explicitly capture a system, governance may still create unintended side effects. For example, formal governance systems can encourage action versus inaction. Even when inaction is superior, governance can also be extremely time and energy consuming. Speed of evolution. A common argument for an on-chain governance is that it can allow protocols to evolve faster. However, there is little, if any, empirical evidence of on-chain governance causing faster protocol evolution. On-chain governance is also extremely nascent, so judging it too heavily is likely premature. What has been demonstrated is the opposite, that rapid evolution can occur without on-chain governance. For example, early Ethereum and Uniswap are protocols that evolved quickly through hard forking alone. This agility can be attributed to a combination of tight-knit communities, lower systemic importance, and high levels of trust in core development teams. What about ossification at later stages? Evolution may slow as some combination of network effects, pointer stickiness, as in protocols becoming embedded in the code of other protocols or applications, and risk aversion set in. Still, if a change is important enough, users and applications can voluntarily opt into it. This usually means a hard or soft fork for a layer 1 protocol and a voluntary migration for layer 2 protocols or applications, as seen with the V1 to V2 transitions in protocols like Uniswap, Maker, Compound, and Augur. Ultimately, if a protocol becomes sufficiently inferior to a new alternative, eventually it will be surpassed and die. This is how evolution works in nature. Individual organisms do not evolve in the genetic code sense. Evolution occurs when copies are made with mutations. This approach has also worked in open source in the past, for example, Linux. Since credible neutrality is the primary value proposition of protocols, erring towards governance minimization over time, even if it means slower evolution at the individual protocol level, will lead to maximal use. Governance minimization enables faster, ecosystem-wide evolution. Most importantly, dependable individual protocols enable faster ecosystem-wide evolution because developers can use these building blocks with confidence. Imagine how much faster development of internet applications would be if every company's code was open source, neutral, and usable by anyone. When is governance valuable? Governance is needed where a core mechanism of a protocol requires human input. Human input is needed when a protocol's response to a particular action cannot be known in advance, or derived from on-chain data, and thus cannot be coded into the protocol. We refer to these mechanisms as essential governance. Areas of essential governance include 1. Consensus itself, for example, the layer 1 consensus mechanism of Bitcoin or Ethereum. Consensus is governance over which of two otherwise valid histories is valid. This governance is tightly constrained. Bitcoin miners can double spend and revert history, but cannot print unlimited Bitcoin. 2. Oracles. Oracles need some form of human mechanism to decide whether or not their data is valid. Areas where governance is likely required include treasury management, so governance is likely required for the foreseeable future. Deciding how to allocate funds is a hard problem to automate, and in complex parameter setting. As one example, Maker currently needs governance to approve new collateral types and set their corresponding collateral requirements. These functions are inherently hard to codify. The suitability and risk profile of a new collateral type, as in some of which may not even exist today, is hard to assess in advance. Some governance can be eliminated over time. For example, Maker could build a mechanism that programmatically sets interest rates, eliminating the need for governance to set them. Governance is often a complex trade-off. For example, the Maker system chooses to allow many different collateral types for the benefit of greater capital efficiency. This, of course, also has the drawback that the ability to handle new collateral types requires governance and all of the system risks, community energy, and complexity associated with that governance. It's possible to build a governance-minimized alternative to Maker with only one type of collateral. Whether or not the system would be better is challenging to assess. Finally, governance may be a feature in some cases. For example, people changing the rules of a game, as in governance, could be a core mechanic of some games or social apps. Governance minimization is not a panacea. While governance-minimized protocols are more dependable, adverse outcomes for some subset of stakeholders can still occur. For example, the majority of participants in a governance-minimized protocol can still choose to hard fork for their own benefit and at the expense of others. However, the cost is high. Setting a social norm of violating credible neutrality causes future potential stakeholders to lose trust, and eliminating stakeholders tends to reduce the network effects and use of a protocol. Forking can also be a feature. Of course, it allows two different stakeholders groups to live on the protocols they each want. Most importantly, eliminating governance in some places does not mean it can or will be eliminated everywhere. It may even make governance more important in the smaller number of areas it concentrates. Crypto governance remains important and ripe for innovation. Well-functioning governance remains vital, especially in areas of essential governance, example of Layer 1, consensus, and oracles. If the point of a blockchain is to provide a ledger of universally accepted truth, its integrity is paramount. Innovation in on-chain governance systems remains an important frontier. Improvements beyond the current naive one token, one vote standard likely exist, for example, quadratic voting and Futurkey, and are important to create. I remain excited to watch those experiments get run and continue to believe we'll see more innovation in governance systems through blockchains than through the real world in the coming decades. Value capture. The extent to which governance is needed to capture value is an experiment playing out in real time. Pointer stickiness, gas costs, user-initiated states, for example, a live bid in a decentralized exchange, which a user would need to reinitiate in a new protocol, and other network effects are some factors that could create defensibility and allow a governance minimized protocol to capture value. Value capture equals use times take rate. The central claim of this post is that use of governance minimized protocols will be higher. Take rate remains an open question. It may be that governance minimized protocols have higher use but lower take rate relative to a traditional company, and where that nets out economically is to be discovered. Separately, many tend to hear value capture and think evil. Value capture can serve a few important purposes. First, it incentivizes creation of protocols in the first place. Second, if governance is needed, governance value capture is necessary to incentivize contributions to governance and for security. For example, to make a 51% tax on governance more costly. Finally, it can help fund further development. Ultimately, only essential governance is defensible. Anything inessential is likely to be competed away over time. Conclusion. Governance minimized protocols will see the most use. It is the core attribute which kicks off the positive feedback loop between trust and adoption as a standard. It also puts powerful basic tools in the hands of all creators, generating more opportunity and faster progress for the entire crypto ecosystem. As crypto grows into one of the most important technologies of the coming decades, it can lead to greater opportunity and faster progress society-wide. Fantastic, fantastic. I don't have that much commentary to add to this article, because I just agree with it completely. And they start with the main point all the way at the top. They don't bury the lead. And that is that minimum governance leads to the highest amount of credible neutrality. And the highest amount of credible neutrality is what enables developers and users to trust a blockchain protocol. Not just a blockchain protocol, but any protocol. And that credible neutrality is what underlies the trust in the system. And what Web3 is really all about. It's about giving sovereignty and self-control to the developers, having the credible neutrality at the heart of the ecosystem. Over the past decade and a half, we've been moving towards an API-first world, where companies and developers focus only on their best feature. They focus only on what they can do the best. And for everything else, they just use APIs. Don't do messaging, use Twilio. Don't do data and cloud, use AWS. And that really works well. The only problem with that is that if AWS shuts you down or Twilio deprecates an API, then your company goes kaput. And that's the big advantage of Web3. If you're building a game and an in-game economy, that no one could shut down as long as the blockchain is credibly neutral. And that's a huge advantage. Also for the developers and also for the players. You know that your NFT will always be yours. But here is where we get to a different kind of application. And this is referenced in here a little bit towards the end, where there are different applications that need different kinds of governance. And in this concept, the game that I was just using as an example is actually the reverse example, because games need governance. They need to be highly curated experiences to be fun. And we've seen this happen in Axie over the past year, where as the game economy changes, the development team uses their ability to govern the in-game mechanics to control the in-game economy so that it doesn't become too expensive for new players or too cheap for the old players. And that's where the governance really comes in. And that's an application that's above the blockchain, and it's completely separate in its credible neutrality. And to make it valuable, you actually need that governance mechanism. So it really matters what application we're talking about, what layer we're talking about, and whether governance minimization makes sense. But for the core protocols, whether it's things like Uniswap or Ethereum itself, governance minimization makes so much sense. It makes things so much more trustworthy and credibly neutral so that they can become real plug and play protocols in other applications and be the building blocks, the Lego blocks for the decentralized Web3.